Welcome! Today we're exploring SuperAGI, a framework for building autonomous AI agents. Think of it as giving an LLM the ability to use tools, remember what it's done, and work through multi-step workflows, all while you keep control over what it can and can't do. Let's see how it all fits together. SuperAGI lets developers build autonomous AI agents that can use multiple tools, work through multi-step workflows, and run continuously. It's like a programmable assistant that can search the web, write code, manage files, and integrate with services like Jira and Slack, all while maintaining memory of what it's done. The stack is Python-heavy on the backend. FastAPI serves the REST API, Celery handles async agent execution as background jobs, and SQL Alchemy manages Postgres models. OpenAI provides the LLM brain, while vector stores like Pinecone and ChromaDB give agents long-term memory. The front end is a Next.js dashboard for monitoring and control. Docker Compose ties it all together. Agents follow workflows. Think of them like flowcharts. An iteration step is where the agent thinks. It prompts the LLM, which decides which tool to use and why. A tool step just executes a specific action without asking the LLM. You can also add wait steps to pause execution and permission gates that ask a human before doing something risky, like sending an email. Here's the big picture. FastAPI receives requests to create and run agents. It stores config in Postgres, then queues a Celery task. A background worker picks it up and hands off to the agent executor, which loads the workflow step, prompts the LLM, parses the response, and executes the chosen tool. Results go into the vector store for memory, and the executor schedules the next step. It's a loop that keeps running until the workflow completes. Let's trace a single execution. The user hits the API to start an agent. Celery queues the task, and the executor loads the workflow. It builds a prompt with the agent's goals and available tools, then sends it to the LLM. The LLM responds with a tool choice, say, Google Search. The executor calls that tool, gets the results back, stores them in the database and vector memory, then schedules the next iteration. This cycle repeats until the agent finishes or hits the iteration limit. The tool system is where the magic happens. Every tool inherits from base tool and defines its schema, arguments, and execute method. Toolkits group related tools, like file toolkit bundles, read, write, delete, and list. At runtime, Tool Builder dynamically loads tool classes from the database, instantiates them, and injects the agent's context, LLM instance, execution ID, resource manager. This means adding a new tool is as simple as dropping a Python file in the tools directory. The LLM layer is provider agnostic. It supports OpenAI, Google Palm, Replicate, Hugging Face, and even local models through a unified interface. A factory pattern loads the right provider from database config, so switching from GPT-4 to Palm is just a configuration change. The OpenAI implementation includes retry logic with exponential backoff for rate limits and accurate token counting using TickToken. Agents can have long-term memory through vector stores. After each interaction, the assistant's thoughts and tool results are chunked using a text splitter, embedded with OpenAI's embedding model, and stored in Pinecone or ChromaDB with metadata like execution ID. Later, if a task seems familiar, the agent queries the vector store for similar past experiences and uses that context to inform its next action. It's like giving the agent a searchable journal of everything it's ever done. Now, a word on the community. This repo shows an archived signal. The last commit was over a year ago in January 2025, and there's been zero activity in the past year. Just one contributor ever touched it. So while the architecture is well designed and the feature set is impressive, this codebase appears to be dormant. If you're evaluating it for production use, you'd want to fork and maintain it yourself, or look for an active successor project. So why does SuperAGI matter? It's a complete framework for autonomous agents with workflow control, a rich tool ecosystem, multi-provider LLM support, vector memory, and safety features like permission gates. The distributed execution model with Celery means it can scale to handle many agents in parallel. While the repo itself is archived, the architecture is a great blueprint for building your own agent orchestration system or understanding how modern AI agents work under the hood.